Alright, so let's look at another example where instead of just drawing the stereographic projection or doing individual problems, we'll be running through the entire set of problems and understand how to do them one after the other. So the question begins with asking us to draw a standard 100 stereographic projection with 0 bar 10 on the south point, and then we have to mark all the major poles associated with 100, 110, and the 111 family. After that, now here's something different that we haven't done before. You are first asked to calculate what the ABC Miller index notation would be given the XYZ coordinates and the given the ABC markings, and also same for the ABDE. You have to find that and then mark it on the same projection. Mark ABC and mark the poles for ABDE. Once you have done that, then you have to calculate the angle between those two planes. Further, you have to draw the trace of ABDE on the stereographic projection, and then you have to calculate the zone axis for ABC and ABDE. Now, what will happen is that if you mess up the part B and get incorrect notation for ABC or ABDE, all the parts will give you incorrect answers or might give you incorrect answers. So you'd want to be very careful, and this is where the pre-midterm one content will be helpful, is to be really familiar with correct Miller notations and being able to get correct notations, right? So we're going to start with this, proceed to finding the notations, mark them on the projection, calculate the angle, mark the trace, and calculate the zone axis. And instead of using a tracing paper that I've been using for the previous videos, I'll just be using a simple sheet of paper. So this is to show that you don't technically need transparencies. So this, for example, is a normal WolfNet printout or a normal A4 sheet. Over here is another A4 or the letter size sheet. So there's no transparency, there is no tracing paper or baking sheet involved. And even with this setup, you can easily do your question. And you can even see in the camera that these sheets are thin enough that they are transparent to be able to let you see the entirety of the WolfNet. And that's all we need. We just need to be able to get a good estimate of where the WolfNet is, and now we can use it. So you don't need any transparencies, you don't need any baking sheets or any other special form of page. Just one WolfNet printed on a normal sheet and another normal A4 or letter size paper. Alright, so let's begin. The first thing that we want to do is take the center and put it down through a thumbtack on our notebook. Cool. Once we have established that, now we can start tracing the outline of our projection. And this is where you can see how you can easily see the entire WolfNet, because this A4 or letter size paper is translucent enough to be able to let that WolfNet be visible from the very top. So, and another thing you can do is that since you have probably watched the previous videos, you could pause this right now and try to first solve this question by yourself. Time yourself, see how much time you require to solve for solving such a question, because you have very limited time in the exam, and this is one of the questions which will take a lot of time and also has a lot of potential for error. So be very mindful about the WolfNet and the projection question. Alright, so we have this. I drew the outline. Now I'm gonna draw the north-south axis and then the east-west axis. Once you have drawn the north, south, and east, west, this will help you keep a good track of the orientation of your result relative to the WolfNet. So even if things get moved around, you can always just line it back up however you want, so that it's perfectly on the north, south, and east, west axis. Alright. So with this, now let's proceed with the question. So it is a 100 standard stereographic projection. So let's write that in the center. And whenever I'm doing these drawings, I like to hold the sheet from one end whenever I'm not rotating it, so things are a lot more stable. So this will become 100, and then the south point is given as 010. Right, so let's mark the south, and remember it'll be a four-fold symmetry, so we'll have a square, so this will be 0 bar 1 0. All right, that was the question. And the next step is to look at the axes. So the 100 is the one that comes outwards. This is 100. The one that goes down is a south, so this would be 0 bar 10. So you can see this is the x-axis, this is the y-axis. So the one that goes up will be, oh, so this is the negative y-axis, so this, the one that goes up will be the y-axis, so 0 10. And then x cross y through the right hand palm rule will give you, or even you could use the thumb rule, this will give you the z-axis, which is 0 0 1. All right, so with that, since we have all, this is the south, this will be the north, this will be the west. Now we can mark the rest of the points. So the north, as we said, will be the y-axis, which is 0 1 0. The west over here will be the z-axis, which is 0 0 1, and then the opposite will be the east, which is 0 0 bar 1. And these are all the four-fold symmetry family poles, a family of poles from the 100 family, for which we use the square notation. Right, now let's go to the ones which have the two-fold symmetry, which is the 110 family, and we'll use the ellipse notation for this. Right, so if you remember from the previous videos, we'll just count 45 degrees and then mark them, and then I'll label them towards the end. So 1, so 10, 20, 30, 40, 45, 10, 20, 30, 40, 45, 10, 20, 30, 40, 45, 10, 20, 30, 40, 45, 10, 20, 30, 40, 10, 20, 30, 40. And you can check from either side. Alright, so we have these markings. Let's do the circumference or the primitive circle. 10, 20, 30, 40, 45. 10, 20, 30, 40, 45. 10, 20, 30, 40, 45. 10, 20, 30, 40, 45. Alright, and let's just label them. How to label them? We just do a vector sum. So 100, this will become 10 bar 1. This will be 101. This will be 1 bar 10, 110. And doing the outside, we'll get 0 bar 1 bar 1, 0 1 bar 1, 0 1 1, and then 0 bar 1 1. Alright, so these are all the two-fold. Now comes the three-fold, which is the 111 family, for which we'll use triangle. And this is where, if you remember from the previous videos, all we have to do is draw the great circle for these two or these two, and then draw the line that is connecting these 2 points, which passes through the center and these 2 points. So this, this, and this, and then find the intersection. And here you can see, even if I don't have a transparency, I'm still able to solve this entire question because it is translucent enough that I can see the wolf net in the back. So I'm just gonna roughly draw, and it might look not translucent enough in the camera, but if you actually check it out on your own sheets, you'll see that it's clearly visible and it's very easy to see. I'm just gonna draw the wolf net. Before that, I'm gonna do the diagonals. And this is where I told another method that you could just rotate it along the northwest axis and then just use that if you don't want to freehand it. And then same thing with the other ones, where you could just use the east-west axis to not freehand it and get like a straightish line. Alright, so then rotate it back to how it was, to have the north, south, east, west. And then I'm gonna continue this great circle, continue this great circle, And then same on this side. Extend the great circle, extend the great circle, and then mark these as your 111 families. Alright, and to get the notations, just do the vector sum of the center with the outside point. So this will be 1, 1, bar 1. This will be 1, bar 1, bar 1. This will be 1, bar 1, 1. Summation of this, and there's vector summation. And this will be 1, 1, 1. Alright, so this is the first question that we just finished. We drew the 100 standard stereographic projection with 0, 1, 0 on the south point, which was right over here. And then we marked all the major poles corresponding to 100, 110, and 111 family. Now it asks you to mark the ABC pole or mark the ABC. Then the question becomes, now you have to calculate the ABC. So if you have memory from your pre-midterm content, you know that you can calculate the intercepts as the first step to get any notation. So let's see the XYZ intercepts for, so I'm doing ABC first, and then I will do ABDE. Alright, so for the ABC, the XYZ intercepts, this point is 1, this point is 1, and this point is 1. So the intercepts are simply 1, 1, 1. Then you do the inverse of these intercepts, which is 1 over 1, which becomes 1, 1 over 1, and 1 over 1. And then you convert it to whole integers, which is, it already is in, so your notation just becomes 1, 1, 1. And then for the ABDE, this is where it slightly gets tricky. Not that difficult, just have to be careful. So let's just do the intercepts, and then we'll do the inverse, and then we'll get the notation. So let's look at the ABDE plane. So the intercept on the x-axis, that is still 1. So let's write 1 here. Intercept on the y-axis is still 1. But you'll see that the ABDE plane is sort of parallel to the z-axis. So it's not intersecting the z-axis at all. So it's parallel. So two parallel lines meet at infinity. So it's intercepting the z-axis at infinity. Now when you do the reciprocal, 1 over 1, 1 over 1, 1 over infinity, this 1 over infinity tends to 0. So we have 1, 1, 0. And this becomes the notation. So 111 is the ABC, 110 is the ABDE. Alright, and challenge is that if you get these notations or this type of question incorrect, all the next sub questions will also give you wrong answers. So be very careful when you find these answers for any planes that are marked here, and make sure you practice them enough. So ABC is 111 in this example, and ABDE, which is ABDE, is 110. Alright, so let's mark them on our projection. So I'm gonna bring the projection back. And alright, so we have this projection. Make sure it's well aligned, the north south axis and the east west axis. Alright, so, and once they're aligned, let's mark ABC. So ABC was 111, so let's find 111. Alright, so the 111 is right here, so this becomes ABC plane. Alright, and then let's find ABDE. ABDE is 110, which will be right here. So let's mark this as ABDE. Perfect. So now we have gotten the next part done. Let's see the next question. The next question is to find the angle between ABC and ABDE analytically and on the stereographic projection. So let me just show you first the projection, and then we can do it analytically as well. So the steps involved in finding angle between any two poles on the projection is to get them on the same great circle. We need to have them share the same great circle. So this is the ABC pole, this is the ABDE pole. Let's rotate them in a way that they can share the same great circle. So I'm going to use that translucency effect and try to figure out what is a good great circle where they start overlapping. So not yet, probably somewhere over here. Yeah, actually right here. So you can see that now I'm gonna intercept this. So they are interacting on this great circle, which is just like this one. And you can calculate the angles from here. So this will be 10, 20, 30, 32, 34, and right after that's about 35 degrees. So this is about 35 degrees. And again, how did we do it? The two poles, they were over here. We got them on the same great circle. So we had to rotate it by a significant amount. You could have also done it the other way, where you could have rotated it counterclockwise, and it'll still end up on this similar type of great circle, and you could have calculated that to be 35 degrees. Either way is fine, as long as they end up on the same great circle. The angle between them, we found it to be 35 degrees. So now let's do it analytically. So we found that through the stereographic projection, the angle is about 35 degrees. To get the more accurate value, let's just do the cosine theta, which is the dot product of the two planes. So that'll be the dot product of 111 dotted with 110. So the dot product, basically you do element wise multiplication and then addition. So this will be equal to 1 multiplied by 1. This is 1 multiplied by 1, then 1 multiplied by 1 plus 1 multiplied by 0. So it's an element wise multiplication. So this and then there's a divided by, the dot product needs to be less than or equal to 1, the magnitude of both the involved planes. So that'll be 1 squared plus 1 squared plus 1 squared multiplied by 1 squared plus 1 squared plus 0 squared and a whole root of that. So this just gives me 1 plus 1 will be 2 divided by, this will be 2, this will be 1 plus 1 will be 2, and then this over here is 3, so root 6. So this is about root of 2 over 3. And if you have your calculators with you, you can do theta as the cosine inverse of root of 2 over 3. And then I'm just going to use Google real quick to do this. So cosine inverse of square root 2 over 3. Alright, and we want it in degrees. In degrees. Alright, and that comes out to be 35.26 degrees. Alright, so you can see this is the exact value. 35 degrees is what we got from the stereographic projection. So this is how you do it analytically using the cosine. And then we also showed how to do it on the stereographic projection by getting them on the same great circle. Now the next question is to mark the trace of ABDE. And just to reiterate, ABDE was 110. And if you remember from previous video, the steps involved for marking the trace is that you take that pole, get it on the horizontal axis, and then count 90 degrees. So this is the ABDE. Let's rotate that so we can get that on the horizontal axis. Alright, so this is where you want to keep the wolf net stable, as stable as you can, and then you can see now it's almost on the horizontal axis of the wolf net. I'll rotate this so it's straight. Once this is on the horizontal axis, let's count the 90 degrees. So you have, this is at about 4 degrees from in here. So 4, and then this will be 14, 24, 34, 44, 54, 64, 74, 84, and then 86, 88, and 90. So it's right on this 110 point. So I'm gonna draw it. And when you're drawing the trace, make sure you draw the entire great circle. Don't just draw these dotted lines. So this entire great circle that I highlighted is the trace of 110, which in the example that I'm taking is ABDE. Alright, so this is the trace of 110, which is right here. So this distance is 90 degrees. And then now we can go to the next question. So after the trace, now you have to find the zone axis of ABC and ABDE. And just to reiterate, ABC was 111 and ABDE is 110. And if you remember to calculate the zone axis of any two poles, the first step is to draw the trace of the two poles and find the intersection. So we already drew just the trace of 110. Let's draw the trace of 111. So the point 111 ABC is right here. And as you might remember, let's just get it on the horizontal axis. You could rotate it counterclockwise or clockwise, doesn't matter as long as it's on the horizontal axis. So that'll be somewhere right over here, based on this wolf net that you can see in the back. Alright, and I'll count 90 degrees. So this is at about 5 degrees here, 15, 25, 35, 45, 55, 65, 75, 85, and then 5 more degrees. So somewhere about here. So this great circle as I said, you would want to draw the entire great circle to show the trace. This great circle that I just drew is the trace of 111, which is the ABC plane in our case. So we have the trace of 111, which is ABC. I counted 90 degrees. Before that, we drew the trace of ABDE, which was over here. I counted 90 degrees. It was this line. And now the main question was to find the zone axis of ABC and ABDE. After drawing the traces of both, you will see that their zone axis, my diagram is slight off, but their zone axis lies exactly at 110. And this is where, because the zone axis, depending on if you calculate the 111 versus 110 or 110 versus 111, this will give you a positive direction, or these two will give you opposite directions. So you could get 1 bar 10 or you could get bar 110. They do represent the opposite directions, but the idea is the same. So that's why it is often good to take the filled ellipse and then also draw an empty circle outside. And then this over here is the zone axis of 111 and 110. Now here it looked almost like that it was lying on 1 bar 10, and we can check that analytically because that is also something that we need to know. So because that is another question, that we showed that location on the stereographic projection, but how to calculate it analytically and how to get the notation for it along with the location. And as you might remember, we have to do a cross product for this. So we have I, J, K. We'll write 1, 1, 1, and then we'll write 1, 1, 0. So this will be I 1 times 0 minus 1 times 1 minus J 1 times 0 minus 1 times 1 plus K 1 times 1 minus 1 times 1. So this is just minus I, this is plus J, and this is 0K. So this is bar 1, 1, 0, or the opposite of it, which is 1 bar 1, 0. So you can see that this will be on the opposite side of stereographic projection, while the other one is on the side that you are looking at. So this one is on the same side, as you are looking. What that means is when I drew this, the filled circle 1 bar 1 0 represents the line that is coming outwards to you. So in this perpendicular direction, normal to the plane. And then the open circle or the unfilled circle is the one that is going inside into the plane and through the table. Right, so this is how you can solve an entire question which involves drawing stereographic projections, marking the major poles, marking a new pole that is not given to you but you have to calculate it through the Miller-Brave indices, finding the angle between the poles through the stereographic projection and analytically, marking the trace of ABDE, and then finding the zone axis of ABC and ABDE, both stereographic projection and analytically. Right. Try to maybe solve this question again by yourself. I'll try to put this, take a screenshot and solve this question by yourself if you can, to time yourself and see how much time it will take. And this is where it's interesting that you don't need any transparency. I was just using a plain A4 type printer paper sheet along with the wolf print in the back. Right. Thank you.